In this video, we're going to discuss how to write an equilibrium expression. The reactions we've studied so far are reactions that go to completion. What this means is that all the reactants are getting used up and turning into products like this equation down here. The hydrochloric acid is being broken down into all hydrogen ions and chloride ions. So we use this one-way arrow that you're used to seeing. However, oops, sorry, I went one too far. Nope, sorry, didn't. But what we're looking at in equilibrium are reversible reactions. For example, evaporation and condensation of water. These things happen all the time, and they happen simultaneously. You have liquid water going to gaseous water, and then gaseous water steam going back to a liquid. We also have that when we dissolve and then evaporate water off of salt. In biology, this happens in your body all the time. Hemoglobin is going to bind with the oxygen in your alveoli, in your lungs, and you get this hemoglobin bonded to oxygen, and then later it's released to the cells within your organism. So this is constantly happening all the time. Now, most reactions do not go to completion. That means that all of the reactants don't get used up. So the system reaches this dynamic state where the reactants are turning into products and products are turning back into reactants. So for this, we use a two-way arrow that looks like this. So this means that we have N2O4 and NO2 constantly going back and forth in the system. So we write an equilibrium constant. We use KEQ. Now you are going to see on some of these slides where it has KC, and you may even see KP, but it's all KEQ, and that's what we're going to use. So if we have our reaction here, where the lowercase letters are your coefficients from your balanced equations, and the uppercase letters are your reactants and your products, what you do is we take brackets to represent concentration, and we'll talk more about concentration later on. But what you need to remember here is that you always put the products over reactants, and you always raise the power to whatever the coefficient is. So my products, remember, are all these things over here on the right. So big D and big E are my products, and we raise those values to the coefficient, all right, little d and little e. We put those over our reactants. Remember that reactants are over here on the left, so big A, big B are raised to the powers of little a and little b, like we see down here. And don't worry about the math. We're not going to do any math with them. All we have to do is be able to write the expression. So in this example, we have nitrogen plus oxygen in equilibrium with nitrogen monoxide. So we're going to write the equilibrium expression. So we start with our products, which is our NO, and we're going to raise that to the second power because there's a coefficient of 2 in front of the NO. And then we're going to put that over our nitrogen times our oxygen. So products, we're raising that to the 2 because of this coefficient here, over nitrogen times oxygen. Now we always leave solids out of our equilibrium expression because what happens, they have the same density, so they have the same number of particles per volume, so the concentration is not going to change. So we leave solids out of the expression. So for example here, nickel is a solid, and nickel 2 oxide in the reactants is a solid. So we leave those out of the expression. We do include gases. Okay, so because carbon dioxide is a product, we put it on top. Carbon monoxide is a reactant, so it goes on the bottom. And we have all 1-to-1 coefficients here, so that's what we've raised to the power. So leave out solids. We also leave out liquids because, again, taking out a small amount of water is not going to affect our overall concentration. So in this reaction, we have HCl that's aqueous. We're going to leave that. Oxygen, that's a gas. We're going to include that. Chlorine, that's a gas, so we need that. But the water is a liquid, so we're going to leave that out. So because chlorine is a product and there's a 2 in front of it. We raise it to the 2. HCl, or hydrochloric acid, notice, is raised to the 4 because that coefficient of 4 right there, and then times our O2 on the bottom. So products over reactants. So just to summarize really quickly, when you're writing an equilibrium expression, make sure you include all of the aqueous species and all of the gases. Do not include the solids or the liquids.